This is a sample of one of the projects that we're going to be resolving at the AI Developer Workshop. We're going to be creating an agent using LangChain, and you're going to see how interesting it is. We're going to be creating an agent that receives a natural language, business level requirement from a user, us in this case. It's going to be coming up with the right SQL to answer that query. But in this case, the agent doesn't even know what the database is about. So it's supposed to inspect the database, inspect the tables, and start like this loop pattern to solve the final question of the user. And we're going to put all this in place. And of course, we know that behind the scenes, it's going to be using the React pattern. Now, there are a few things mentioned in this project that you might not know about, even the React thing that I just mentioned. And you have to understand that is covered in previous weeks of this workshop. And the projects have already been created and recorded and all that. So that's why everything is already mentioned. So again, if you catch something that you don't understand, it's because it has been covered in previous weeks. So again, this project is going to be pretty interesting. It's going to show you the power of LangChain to create a functioning agent in just a couple of lines of code. And we're also going to see the magic that happens behind the scenes, because we're going to see this agent actually reasoning. We're going to see how we ask a high-level query. It's going to understand it has to inspect the database, and it's going to make mistakes. And we're going to see how to make the agent recover the mistakes by itself and then execute the query. And it's going to all do all that with just a couple of lines of code, a single create agent function, middlewares, error handling, and of course, tools to actually execute the query. So again, if there are things that you don't get, it's because they were covered in the previous weeks. It's just a sample, so you have an idea of how these sample projects guided with solutions work. And of course, there are more in the agents side. This is just one of them. I think it's the second one in the whole series, and there are like 10. So you can see how it's gone. All right, I'll let you to actually start working on it. In this project, we're gonna be writing a SQL query assistant agent, right? It's gonna be an agent using LangChain that will reason in order to answer queries from the user that are gonna be posed in natural language, right? So our business level talk, right? We're gonna be able to say something like, show me the top best-selling products, and the agent is going to be able to understand the database, understand the structure of it, the tables, to finally create a query. And it's going to do everything by itself. It's going to be a pretty smart agent, I assure you. But what we're going to see here is the power of the agent framework in LangChain, especially the React design pattern we discussed before, right, in our previous week. So basically the goal is that, and it's pretty much the same thing that you do. Let's say that you are hired, for example, at McDonald's tomorrow as a data analyst. You're given access to the database. It's your first day. And basically the manager comes and says, show me the top 5 best-selling products in Asia. You're going to have to start doing this reasoning effort, right? You're going to start first, you're going to open the database, you're going to start checking the structure, what tables are there, right? Eventually, you're going to fixate in something like the sales side, right? So you're going to be a sales table or a purchase table or order or something like that, right? So you're going to identify the few tables that you think are the ones that are going to answer that question. And then you're going to start looking into the details of each one of the tables. You're going to see the columns inside. You're going to see where the data is stored. You're going to see how it's related, how you can join, right? So you're going to do this iterative process that is going to start gaining insight, let's say, into the structure to finally write something like select star from sales, join, customer, whatever it's going to be, right? The same thing we want to do with the agent. And to do so, again, we're going to be using LangChain agents, not LangGraph. LangGraph, we're going to use it in other projects. For now, I'm going to use just LangChain with the create agent function. And you're going to see it's extremely, extremely powerful to create reasoning agents. So let's explore a little bit of the project first. There are 3 databases here that you can use: Aquila, Chinook, or Travel. There are sample databases that we use in our databases course. And You can, of course, include your own if you want to try by yourself. And basically, we're going to be at the beginning starting with a very simple objective. We're going to mostly use Sakila for all these examples. But again, you can try the same thing with any of the databases you have here, and you can also upload your own. So the first thing we're going to do is we are going to create a model object, right? Because we're going to be using, in this case, we're going to use OpenAI, and I'm started with 4.0 Mini. It's a model that has a little bit of reasoning, so it works well, let's say, for reasoning agents, but it's not perfect. So we're gonna see a couple of errors in the middle. We're gonna see a couple of things during the project. As you know, we're gonna be using Open Router. So if you go to your .env, you are going to be able to place your API key for Open Router or OpenAI, whatever key you have, you can place it in .env. You can actually replace this if you want. If you wanted something. So the first objective is the following. We need to create the agents, and this code here is given. We are not supposed to change it. And we're going to initialize it with assistant prompts, and we're going to define a tool for the agent to use. In this case, it's going to be execute query. So there's just one function. This agent needs only one function to function, right? So it needs only one tool to be able to do the task that it was assigned. And finally, we have the prompt. And again, this is given. You don't have to change it. Using the database Aquila SQLite, show me the top 5 actors that appear in the most films. All right, so it's a little bit of a complicated query. It requires a little bit of a join operation, etc. There are a bunch of sample questions you can check here, by the way. So if you want to try it, we have the natural language query and also the SQL code for you to compare what the agent came up with. So this is the first introduction to these create agents. So we're going to start very easy, and I'm going to show you basically how it's going to work. Our agent we are going to create the agent. We're going to initialize it with access to different tools, right? So in this case, we have only one tool, which is execute query. The agent will be able to reason, right? Of course, invoking, in this case, OpenAI model, can be another model, can be any LLM. And eventually it's going to use these tools in order to answer the query by itself, right? So it's going to be something like, how can I query the film table? That's going to be something that the agent is going to reason. And eventually when it has the answer, what it's going to do is going to just execute the query tool right here. So how does this reasoning work? Let's actually go ahead and try to do the project objective 1 first. We're going to complete it. And then I'm going to explain to you how this reasoning is working more or less. All right. So the first thing we have to do is write the function execute query. This is fairly simple because we have the code written here at the top. That is just going to be read the path, execute the thing, and that's it. So what I'm going to do is I'm going to go ahead and I'm just going to copy the code and paste it from my solutions. You can see. So we gain a little bit of time. But if I execute this as it is, you're going to see that this is, I have an import model. You're going to see that this will fail because the tool needs a description. It's not enough to say the tool is execute query. It has to explain to the agents what is the power that it has, right? The agent needs to know what each tool is doing, especially because in more advanced projects, we're going to be using multiple tools combined. So we're going to add a little bit of a docstring here, execute an arbitrary SQL query in a SQL native, whatever. It's fairly simple, the docstring. And then we need to give the agents an initial system prompt, right? In this case, the system prompt ideally will be fairly generic, giving the agents the high-level goals. So it can function properly. So it's going to give it like an overview of what's going to receive, and then at the end, the objective of what it should reply. Potentially, we give it like stylistic comments, like something like reply only with text, don't use Markdown, or reply with a table, this type of things, right? But as the model we're using is not that smart, and we're actually be able to compare this with the behavior with different models, we're gonna need to give it a little bit more information. So again, the agent is aware of the tool. So we're gonna say again, we're gonna start high level defining our prompt, as we saw in our first couple of weeks, that it's important to always come up with a plan for our prompts. We're not just sitting and writing. We need to make sure that we have a clear plan of what's going to be contained in that prompt. So we're going to say something like at the beginning, we are going to give it something like the role, right? So you are a helpful assistant writing SQL queries. That is important. At the end, we're going to say something like, for example, at the end, we're going to say something like, reply in Markdown. We're not going to add any style because we don't want to complicate the agent at this point. We're just going to make sure it works. We're going to say something like behavior, expected behavior. So we're going to tell the agent that it will receive a query from the user in natural language, and it's supposed to translate it into SQL, blah, blah, blah. We're going to give it some technical caveats, tech clarifications, to put it away. All right, so we're going to tell it potentially that this is only SQLite, that it will need to, the user query is going to be very high level, so we will need to explore the tables and the structure, etc. Right? And ideally, again, at the end, some style notes that we're not going to ask. But this should be potentially all of it. Now, to be honest, doing multiple tests, I found that it's usually better to include a little bit of the clarification of the tools available for the agents in the system prompt. Although this will violate a bit the principle of not duplicating things, because potentially if we're already including the tools and the doctrine, we should not need to duplicate this thing in the system prompt. But again, for the sake of having the first version of this agent working and then iterating to improve it, we're going to add it. Ideally, you're going to have this thing working. You're going to go back to your system prompts and you're going to start removing all these nuances so you get something that is more like production level. So here we're going to do tool mention. We're going to do a brief tool mention, right? That's a goal of what we want to achieve. Potentially, we'll remove this in the future to avoid this duplication right here. All right, so I have the prompt already written. What I'm going to do is I'm going to copy. I will not change this, so I'm going to redefine the variable. We're going to create the agent, and this is it. The agent receives, in this case, only 3 parameters. The model that is going to execute. In this case, we're using GPT-4o Mini. The tools, in this case, just one, execute query. And we're going to pass the system prompt that we have just crafted. Then what we're going to do is we're going to invoke the agent with the invoke method that will receive, in this case, a list of messages. The first one is going to be the one from the user. So let's just go ahead and evoke it and let it run. It's going to take a little bit of a couple of seconds. And by the way, throughout this project, we're going to see multiple errors here and there, because small maximum context length, for some reason it added too many tokens. I don't understand how that's possible, and it's been resolved. It took me another attempt, but basically this just worked without changing anything. It's just the non-deterministic nature of models. And basically we have a result here. Here are the top 5 actors who appear in the most films from the SQL database. Actors and actresses, clearly. And we can potentially check this because we have a query here, and I think we have the same information. To be honest, if you run this multiple times, you might see that the results are different because the agent will make mistakes. This is the most important thing, and we will learn how to evaluate agents in our evaluation week. But for now, you need to understand that if you run this enough times, the agents will fail, as you saw, potentially, but also it will return wrong things. Because again, the model is not that smart, and we only have one tool, which is the execute query. We don't have any way for the agent to check itself. But again, it works. And what I want to show you is a little bit of what happened behind the scenes, right? So we have this utils function, which is a format result messages, which shows all. Let's actually close this thing that we don't need. There you go, better. So we have here the list of all the messages that the agent executed. And let's actually try to dig a little bit deeper on how this agent works, right? So this is what I'm going to show you here. Remember about the React pattern we saw in our first week where we talked about prompt engineering. We have this way of the React pattern is basically reason act. It's something like what's the best next step for us to apply? That's what the LLM is asking itself to then finally execute a given function in the local context. So what's going to happen here is that if we provide a given query, in this case, I simplified it, give me the top 5 films by length, there's a setup step, as usual, as we saw in our first week. There's a little bit of reasoning, right? So this is the part. It's like the reasoning is the agents, of course, talking with the LLM, is going to ask itself, what's the next step here, right? And the next step most likely will be to do something like, well, I probably need to inspect the database first to see the names of the tables, right? I need to see what I'm dealing with. And with that reasoning, it's going to invoke the tool saying, what's a query? It describes schema. This is non-valid, but it's basically a query. It's going to say execute query, Sakila, describes schema. And the tool is going to reply or respond with something. In this case, it's going to give it a list of tables. And then the reasoning continues. The agent goes to the next step, which is like, okay, there's a film table. So this is basically what matches the user query. I need to inspect the table film to analyze the columns because the length here from the user could be, the name of the column can be anything. Could be minutes length in seconds, could be multiple things, right? So basically, it will try to potentially describe the table film, and it's going to give it something like table film. The columns are film ID, title, release year, length, etc. And this is when the React continues, and the agent is going to realize that the table film has a length column. I can sort by that column, blah, blah, blah. It's going to finally execute the query. And here's when it's finally going to realize that it's time to give back these results. The top 5 films by length is going to answer with the given results. So this is the same thing we're saying here. And again, if you run this 1,000 times, you might see 1,000 different answers here. Sometimes something that I've noticed that Sakila is a fairly popular testing database or sample database. So sometimes the model will not even try to check the tables, just assumes the name. Like in this case, for example, the agent didn't even try inspecting the database. It already knows there's a table actor, there's a table film actor, because it knows it from the context. Of course, we could potentially say something like always start with a given operation in our system prompt. We could give it a different tool that is more explicit. Something like explore database, right? Or we can just, again, if the database is not known, most likely the agent is going to start by looking, right, at the database schema. But anyway, the agent knows that there are 2 tables. One is actor, the other one is film actor, and it's doing all this by itself. You guys just saw this, just a single line. Of course, 3 lines split, but it's a single line, a system prompt, the tool, and that's it. And the agent starts this while true reasoning, right? It's like, I'm checking this, if it works, and it's doing all these things. So basically, there is the user message. There are two tool calls in the same message. And it's going to be something like describe the table. It's going to be like actor ID, first name, last name, blah, blah, and then there's a little information. And then directly goes with the query. So now it knows that by combining the film actor and the actor tables, all right, and I have the solution here. So film actor and actor correctly guessed, and counting on the number of film actor film ID, it will be able to answer the query. So it comes up with a query, executes the query, and then just formats the results, in this case using Markdown nicely. So again, as a reference, we have the query. It's the same thing. The agent actually got the thing done with this simple process of reasoning. Go into the introspection. What should be my next step? Potentially describe the database. What's my next step now? Potentially describe the tables. Show me what's the tables. And then potentially building the final query to execute for the user. So again, we can see that here. Okay, second objective, context and dynamic system prompts. You guys will see that we're asking the user to give a little bit more too much information here, because the user must say where is the database located. If you guys think about this in a web interface way, right? There's gonna be something like, for example, a single query text area in a web interface, but then there's gonna be something like a select, right? A drop down. Which is the database do you want to pick from, right? So it's not gonna be. We're not just gonna give liberty to the user to say select anything you want and put it right there in the prompts. So to do so, we want to make sure that we support the idea of a context. So we're gonna invoke this agent, and I'm starting from the end. I'm showing you what's expected outcome of this objective. What is gonna be the thing that we're doing, and then we're gonna trace back to the final way of actually doing it. So we're gonna start with the context, right? We're gonna invoke the agents. We're gonna invoke it with a more generic prompt. We're not gonna include the database here. The database, which is again more contextual information, is going to be passed in an actual context. So we're gonna say execute this thing in this particular context, and the context contains the name of the database file, right? To do so, what we need to do is to create an agent with two new things that we didn't do before. In our previous step, we created the agent passing as system prompts, right? So it's right here. We pass model tools and the system prompt. The system prompt was static. So let me copy the system prompt here. What we want to do here is do something like, I don't need to copy, we're going to use something similar. What we're going to do here is we're not going to pass the system prompt directly here because it's fixed, it's hard-coded, it's static, right? It's frozen. What we want to do is we want to create a middleware that will generate dynamic system prompts based on the context. Okay, so we're going to do something like, you are a helpful assistant, answer the user query. The database is located at, and here we're going to pass basically context at database path, right? So basically we want to be able to generate dynamic system prompts when the user invokes the agent. All the system prompts are going to be different. Of course, if you invoke the same thing with 2 times, it's going to be the same, but conceptually speaking, the system prompt is adapted to the actual use of the user. So let me show you first. I'm going to copy here from my solution. I'm going to show you first the system prompt so you understand what I'm saying in a little bit more detail. And again, as you can see, there is a variable that we're going to be doing replacement right here. This variable comes from here, and it's defined in the context that is initialized in the agent. I'm sorry, there's a little bit of back and forth here, but the idea is that when you create the agent, you will define the schema of the context. The context has a single parameter, which is in this case database path, and we're gonna do just this, and we're gonna say that it's a string. That's it. Finally, what we need is this middleware. What it's gonna do is it's gonna dynamically inject a system prompt anytime that the user, anytime that the agent is invoked. Let's inspect very quickly here the database path prompt. What you guys will see is that it receives a model request, right? The model request will be able to extract the context at runtime. So I'm going to just go ahead and copy the solution so you guys have it simpler for now. Just going to paste this thing here. And here we're going to analyze the code. The code basically goes, we get the database path from the context, as simple as that, and we generate dynamically the prompt. So we start from the prompt templates, and we just format it with a simple format function. So given our context objects, our dynamic prompt, and the middleware, we can now create the agents. I'm going to test it. I'm going to give it a simpler query. Show me the top 5 movies by length, released in the year 2006. It made a mistake. Let's actually take a look at the error that it made. No such table movie. Interesting. It didn't even try analyzing the database. So let's go again. Let's ask the agent to do it again. We're gonna execute again. We're gonna be able to catch these errors here in our next objective. Do it again, because clearly there's something wrong with these agents. Until at some point it will have to pass, right? If not, we can do something like there. It seems like it worked. Gave me the answer, and we're gonna execute. We're gonna take a look at the. Sorry, let's go here. This is the list of messages. So table info, movie, release, all these error queries to finally nail film, to finally create the query that it needed. Again, at the beginning, we could potentially, we can try this right now, right? Start by first checking all the tables available in the database. This should be your first step. Once you know what tables are available, you can start asking for more information. You can ask for details for the tables. For the tables. Let's actually see. This is something I'm coming up with you guys here, so it might not work again. We're gonna see the error might happen. There you go, still happens. Because the what's what you call them name? It's like the agent is making like these mistakes with something. Eventually what I want to try is to potentially like route the agent to finally create no such column name. Let's to finally see, I don't know where I put name. It's clearly trying to do a query. Again, we're gonna see a little bit more in the observation path, but again, it's like this is not very deterministic, and we're gonna have to try it multiple times in order to understand what's going on here. So moving on, to actually catch all these mistakes, what we're gonna do is do a little bit of error handling. So we want to avoid this particular thing. The agent is allowed to make a mistake. So again, if you are, let's say you are the assistant, right? And I'm asking a question. You're a data analyst, first day in the job, and I'm asking you to do something, and you make a query that returns an error. Your day is not done, right? It's not that just like, oh, I made a mistake. I'm going back home. You're like, you're gonna recover yourself. You're gonna basically pick it up, understand where was your error, and finally come back again to the go again to the path, right? So in this case, you're gonna try to do some query that involves name. And you're gonna say, oh, there's no name here. You're gonna change it. You're gonna recover from the error and go back into the task. So that's what we want to achieve with the error handling step. We want to create a new middleware. Sorry, my bad. Here, a new middleware that will catch any errors from the execute query thing to finally to give the agents the possibility of recovery. Right, that's the goal. To do so and to force the error at the beginning, although we can go back again to the previous example and say it's live, what we're going to do first is we're going to create a strict version of the execute query. So if you guys check all the queries that the agent is writing, pragma title, the agent is clearly, which is okay, right? It's using capital uppercase characters for the selected reserved words from SQL, which is okay. This is the ideal way to format SQL. But we're going to trick it. And we're going to say that the agent can only write queries in lowercase. So this will fail if any of the queries are written with any uppercase character, right? So we're going to do something like this is going to fail because select title from film, but this will not fail, right? This will just pass as expected. Of course, we have to go ahead and write the actual code. So I'm going to copy again what we had before. I'm going to paste it here, the rest of the previous code. There. And finally, this will, of course, create the query that we want. Let's remove this for a sec. So basically, if we leave this as it is, let's duplicate this line. And without the error handling, this will probably fail immediately because the agent will try, there you go, value error. We're going to see our error. Your query can't contain any uppercase characters. I have the typo there in uppercase again. So the agent is clearly failing. What we're going to do is we're going to create this handle tool errors middleware that is going to wrap any tool call. So before, we're going to have an opportunity to deal with the tool call before and after. And this is the beauty. We're going to be able to do something before and after. And in this case, in the after, we're actually going to recover the errors. What we can do is afterwards, we can also add a little bit of logging to understand what was going on in the previous one. All right, so this function is extremely simple, to be honest. If we want to just do it simple, we're going to do just return handler of the request. That's it, handler. And this will execute. So basically, we have an opportunity. This is the tool call. Tool call results. This is tool call results. So we can do anything before, or we can do anything after. This is the opportunity for us to do anything before or after that tool call. Now, of course, what we can also do is write this in a try except, right? So try except. I'm going to do something like tell the agents that this particular tool call failed because of a particular problem. To do so, we're going to use the tool message thing. So here we're going to do something like return tool message contents. I'm going to say something like the tool call failed because, or we can just put here the error. We're going to just use the exception E, right? We're going to just put the error here, and the agent is not going to have the details. We will also need to include the tool call ID. Each tool call, as we saw in our previous weeks, has an ID that we need to keep track of. All right, so I'm going to copy the working code because what I have made is kind of a mess. I'm going to replace it all together, but basically it's the same thing. I'm going to move on. Again, we're going to try to return the handler. In other case, we're going to just, if there's an exception, we're going to tell the agent that there was an exception in their tool execution. So here what we're saying is that some error, some things here could potentially just be an error, and that's okay. It's going to keep populating the list of messages, and the agent is going to be able to see the previous error and ideally recover for the next execution. So we have the strict execute query function that anything that is uppercase will fail. And finally, we're going to create the agents, but we're going to create the agent now with both middlewares, the database path prompt, the dynamic one we created before, and the handle to errors middleware. And here what we're going to do is just try to execute. And this might take a long time because the agent might be making a bunch of mistakes, and we don't know. In this case, it was fairly quickly. It might take a little bit of time. And we can see all the problems that here arise. So this is a whole history of the execution of the agents. Show me the top 5 movies by length released in the year 2006. The agent didn't even check the database. It just went ahead and said, select name, length, blah, blah, blah. Of course, these uppercase characters made the tool call fail. And it said, please check again your input and try again. Your query can't contain any uppercase characters. Try again. And now it tried the same thing, all with lowercase. All with lowercase? For some reason, please check your... Oh, here it is. Click check. So it said select name, length from the film where release years 2006. And please check your input and try again. Not such column name. So this was the previous error we were having. Finally, it did something like select title length from film where release years 2006, order by length. So basically, it did this particular thing to finally arrive to the answer. And again, as we're saying, this agent is not like extremely smart because it's not even checking the database structure on the tables. We're going to see in another project how to actually improve these to make it a little bit more smart. All right, so if we execute this a couple more times, let's actually do it again, see how it goes. You might see that this takes I actually sat for like 2 minutes on one of these agents because it was like coming back and forth. It's like sometimes the agents start diverging before actually getting something, right? So here it's interesting, right? It tried a query. It said it can't contain any uppercase. It then created a query without any uppercase, but with name again. And then it's like, okay, I'm done. I'm not going to keep guessing for name. I'm going to go ahead and get the description of the database with this query. But it got again the error. Like your query can't contain any uppercase characters. So then it's like, okay, I'm done. Pragma, table name, film. It got all the details of the tool result to finally execute the right query. But again, there's no guarantee here that this doesn't keep going on and on and on and on. Like the previous example that the agent was just guessing column names, you can have that happening a long time. I want to avoid potentially that. So we want to give the agent restrictions. I want to say something like, we're going to give restrictions like, hey, you can execute this tool call only 3 times. If you take more than 3 times in this particular thing, we're not gonna let you keep running. So for that, we're gonna use another middleware, but in this case, the middleware is already built in. This is the beauty of LangChain. What we're gonna do is we're gonna use the tool called middleware, and if you go to the documentation, as we saw in one of our lessons, you see that there's this built-in middleware that lets you create something like the tool called limit middleware, and it can be either global, like how many in the entire agents. If you have 5 tools and you put run limit 10, at most there might be only 10 tool calls, or it could be per tool, right? So let's actually go ahead and do it because it's going to be a little bit more clear. So we're going to take this here. We're going to first initialize, import these things. I want to create, we're actually going to create these two, one global and one for the tool. So the global one is going to be, we're going to put something low. We're going to do like 3 and 3. And the thread one is about state, something we're going to see also in another projects. So if you're keeping states in thread of conversations, let's say, you're going to be able to actually limit per thread. So this is interesting. And then we're going to do it for execute query, right? That's the name for function of our tool, execute query. And again, we're going to do 3 and 3. And we're going to call this tool limit. I'm going to do this global limit. We're going to create the limits, and we're going to need to recreate our agents here. Yes. And we're going to pass, as you can see here, we're just going to pass our limit. So we're going to pass first let's use the tool one. So tool limits. That's it. So we have the execute query function, which is the strict one, the middleware's dynamic prompting, the handlers, and the final tool limits, and the context we know it. I'm gonna give it a run. We're gonna see where it ends. I'm gonna copy also. We're gonna be able to see the messages. And let's see what did. So here it is. Execute query. There's an error. Your queries contain an uppercase character. Execute query again. It said it tried once again about the name. Try it again with title. And that's it. Nothing happened. Let's actually start again. Maybe we can give it a more complicated query. We should be seeing the error of the thing. Let's actually do this question. Go list. Oh, here it goes. So in this example, it tried again with uppercase, failed, tried again with name, failed, executed a table info film with uppercase, failed, and it tried to execute again all lowercase, and it hit the limits. Tool call limit exited. Do not call execute query again. By the way, these two tool calls are in the same message, so that's why the AI seems like it's not that you tell it don't execute query again and it keeps executing. It's actually all part of the same message. Finally, the AI says something like, since I have reached the limit for executing queries, to proceed, I'll need to wait before querying data from information. So basically here we're saying it that it got only 3 opportunities to actually execute this particular tool. And we can see how we can limit this particular tool call or a more global limit that affects all the tool calls, which is going to be the same thing in our case because we only have one tool. Okay, and finally, it might be interesting for us to make an agent, force an agent to return structure outputs, right? So it's not just text. We want to return structure output. Of course, we can manipulate the system prompts saying something like, hey, return JSON or don't return Markdown. But we know that that is not effective, as we saw in previous weeks. So we're going to force the agents to return structure outputs. In this case, as this is a kind of a dummy example, we're going to force it to return films, which is a list of film, which are two custom Pydantic models. Of course, the query that you make cannot be about something that is not films, right? Because we're forcing the agents. Kind of a dummy example, but that's the way we are doing. So let's go back again. I'm gonna copy and I'm gonna go back again to the previous the previous tool call, because to be honest, the other one that was forcing the query to be all lowercase might introduce problems. And then we're gonna give it what else? We're gonna go back into the top. And as usual, what we're gonna do is we're gonna create an agent, right? So we're gonna do this thing. We're gonna create an agent with all the things we saw before. We're gonna pass any tool limits, handle errors, and database path prompts, execute query. But we're gonna add a new parameter, right? Which is gonna be the response formats parameter. And here we're gonna import the format types, which are either provider strategy or tool call strategy. This is the second one. I'm just gonna do something like response formats. Response formats. We're gonna use a provider strategy with a list of films, which is the model films. So checking again, we have the model itself, the tools, as usual, a simplified execute query. We have the same middlewares, database path prompt, and handle to errors. And finally, we're gonna force the model to respond with a films using the provider strategy. And we're gonna talk about it in a second. Finally, let's execute it. Let's try to change this so we avoid so many errors. It might happen, as we saw already. What's going on here? Another error. For films that were 25 validation errors for film. 25. Not even once, 25. Let's actually change for a second to tool strategy to see if this potentially works better. And I'm going to explain why. But if not, we have to just go back and forth with the errors, the non-deterministic nature, fixing things, changing things, etc. So we see it's executing. It took its time. We're going to see the result structure response. We have a list of films. So we're going to be able to do something like for film in this print film dot film ID, right? What is for film in films? So we're gonna be able to interact with these objects as they were normal Python objects. That's a goal right here. Let's actually explore the messages, the message chain. And this is, by the way, the final activity. We're going to be able to continue with the rest. Let's actually explore the message chain, and we're gonna see potentially. Oh no, it just works. Um, yeah, it just works. I'm gonna go back again to the provider strategy. That seems to be a bit more erratic. Yeah, there's a validation error. So basically, there is some error. We can definitely log this, and we're gonna see a lot of this in the um field required, type missing, input, film ID, title. So there is one replacement cost, rental rate. So there are issues with the model. So basically, if we simplify this a bit, right? So we do something like we simplify these structure outputs. We're gonna be able to have something or repass more. Like if we look at the tool calls, right? We might see that the thing is not always passing or always selecting all the parameters. So select title length from film. In this case, it's missing a bunch of parameters from the table film itself. But in our model, those parameters are actually required, right? So for example, rental rates, rental duration, these are all required. So if the agents didn't realize that the the structure outputs needs some specific parameters, it will need to make them up, right? So basically, it's a little bit of what it's trying to do right here, and that's why it's actually working. So as usual, it's gonna be a combination of a better system prompt, some more lenient structure outputs, and of course, we're gonna cover much better strategies once we actually get into the details of writing the state machine of the agent by ourselves. So in this case, we're just letting the agents, which depends a lot on the model, by the way, to do whatever it wants to do. But we know that that might not be the best recipe because some agents are going to just come up with new things randomly. They're going to make up things, they're going to hallucinate, as it happened. So once we have the control using LangGraph or other tools to actually direct the agents, we're going to have much better results. But again, takeaways from this project is the idea of create agent. It gives us a very good result pretty quickly. We saw a few drawbacks, but then we saw how to start iterating with the middlewares and all that to have a little bit more control. What follows are going to be more advanced projects covering the line graph side and true AI, but basically we're going to be able to create agents that are a bit more explicit. We're not just at the mercy of whatever the agent is trying to do. We're going to direct the agent to do whatever we want it to do. Okay, and finally, as promised, a little bit of different examples. I quickly run something with Sonnets. That is a much smarter model. You can try Gemini, you can try GPT-5. Basically, asking the same things, we can see that the behavior is fairly different. So in this case, for example, what Sonnet does is starts by looking into the structure of the database first. This is the first step, like what are the tables? And then it realizes that the table film is the one involved and it actually asks for the structure, and it gets all the structure, and then it crafts the query. So again, the agent is a combination of the prompt, the reasoning, the model, and of course the architecture we create, but we have to expect a little bit of variability with different models and different behavior.